Hello. In this session, we'll discuss about selenium dioxide. Selenium dioxide is an important oxidizing agent specific for the oxidation of reactive methylene and methyl groups. Particularly for methyl and methylene groups oxidation purpose, we use selenium dioxide. Selenium dioxide formula is SeO2. It is selenium dioxide. It is prepared by metallic selenium oxidation using oxygen of air. You selenium dioxide SeO2. This is catalyzed by nitrogen peroxide. Nitrogen peroxide rarely we use N2HO4. It is known as nitrogen peroxide. Nitrogen peroxide is the catalyst, and here selenium on oxidation gives you selenium dioxide. Selenium dioxide is very specific for the oxidation process, particularly if you are having CH2C double bond O group. When selenium dioxide is used, it will become C double bond O, C double bond O. So you can say these two hydrogens are oxidized. Or you can take methyl ketone, selenium dioxide when you are using C double bond O, this is converted to CHO. Double bonds, triple bonds and aromatic rings, these generally activate the methylene group. When such kind of groups are there, the oxidation will be much easier. The reaction is generally carried out in the presence of acetic acid or acetic anhydride, and a little temperature is required around 100 degrees Celsius. Alcohol can also be used as diluent. Very important reactions. Aldehydes, ketones we can use. The mechanism, the expected mechanism is like this. C double bond O CH2 group, if it is like this, it is undergoing the change tautomerism to form C. This is OH double bond CH2. This double bond CH2 part you can show like this: double bond carbon hydrogen. Sorry. Yes. So C double bond C. One carbon is having hydrogen, another carbon is having OH. Tautomerism is known to you, and this hydrogen is shifted here simply. Catalyzed by acids or bases, anything. Now here, selenium dioxide actually when reacts with water, it forms H2SeO3. H2SeO3 is the acid, selenious acid. Selenious acid H2SeO3. Expected that first selenious acid is formed and selenious acid is going to do the rest part. How the selenious acid is? It is OH, OH and double bond O, you can see. This proton is attacked by this OH group. So when proton goes, this bond is shifted here, and this bond is coming to oxygen, and this bond is shifted to selenium. Selenium is taking the bond from oxygen. Now it looks like carbon. This is double bond oxygen. This bond is shifted here, so it became double bond. Then this is single bond, one bond gone. This is hydrogen, you can show. Now this is attached to oxygen, which is attached to silicon, which is there for OH. Now See, this OH group and this proton is out, the selenium is out, this is taking this proton. So minus water, minus selenium, and the part is converted like C double bond O, C double bond O. It is not 100% correct. Maybe the mechanism is not clearly known, but this is the most expected mechanism. What happens is, first SeO2 reacts with water to form H2SeO3, which we are calling a selenious acid. The selenious acid is attacking on the enolic form. This is enol form, this is keto form, and this is enol form after tautomerism. From the enol form, the proton is lost, and this oxygen is forming a double bond, and this double bond is attacking on this oxygen. This bond is shifted to selenium. So H2SeO3 selenious acid now converted into selenium. H2O is removed, and finally you are getting this compound. The important examples, mechanism, when it is not clearly known, you can expect questions based on this. So many questions are there. We'll discuss all possible questions on this. For example, CH3CHO is given to you. Selenium dioxide, no other conditions, simply selenium dioxide in the presence of acetic acid at 100 to 140 degrees Celsius, you can say. CHO, glyoxal. If you are having ketone, CH3C double bond O CH3, when you are using selenium dioxide, it gives you CH3C double bond O. However, there, this is converted to aldehyde. Methyl glyoxal, you can say this is methyl part. Similar type of reactions you can take. If you are having phenyl group, C double bond O CH3. As we know, this is acetophenone with the selenium dioxide. Expected is right, C double bond O. This part is converted to aldehyde. If you are having COOC2H5 taken twice, this group is now known as active methylene group. This is diethyl malonate. When diethyl malonate is oxidized by selenium dioxide, this part is oxidized. You can simply show like this, COOC2H5 taken twice. Double bonds, triple bonds, and aromatic rings activate this one. In that way, this is a good choice. Diethyl malonate can be converted into diethyl mesoxalate. CH3, CH2, CO, CH3. Now both sides options are there. When both sides options are there, you can see this is active methylene group, this is also active methylene group. Generally, CH3, CH2, C double bond O, CHO. This is the major one. Of course, it is also formed. When two sides possibilities are there, you can take both sides. And some other typical examples. If you take this compound with a methyl group here, this is called alpha picoline. When this is treated with a selenium dioxide, this is CHO, alpha picolinic aldehyde. If you are having two phenyl groups, this is the part which is to be oxidized. Benzophenone is found. It is diphenyl methane. Diphenyl methane is oxidized to benzophenone. If you are having ring, cyclohexanone, when you are using selenium dioxide, it is giving you cyclohexane 1,2 dione. These are some important reactions. Generally, engineering entrance level examinations and all this is very much useful. But few other cases are also there. We'll discuss those cases also. Selenium dioxide is special in those cases. Allylic hydroxylation and oxidation. The methylene or methyl groups alpha to the most highly substituted, remember this point, and the double bonds is hydroxylated according to the order of CH2, CH3 and CH groups. First CH2 group, then CH3 group and then CH group. This is the priority order, and most substituted is first rule. This part is going to be hydroxylated. See some examples you will get easily. CH3, CH, double bond C, CH3, CH3. When you are using selenium dioxide, hydroxylation reaction, these two carbons, if you see double bond containing carbons, this is less substituted, this is more substituted. More substituted is first hydroxylated, so don't touch this side. Any one of this group you convert into alcohol. Hydroxylation. Hydroxylation of allylic carbon, you can say. See one more example. If you are having 5 carbons, double bond is here and this is having methyl. Now if you want to go for selenium dioxide, now this you can see, in this case double bond, this is less substituted, this is more substituted. In this it is methyl group and this is CH2 group. Which part you expect? Yes, exactly. Here OH comes. This is what we are saying. CH2 first hydroxylated, then CH3. Don't confuse with this example. I will give you one more example. You can see 5 carbons, double bond at second place. This is methyl. Don't confuse now. When you are using selenium dioxide, it is CH2 group. This is CH3 group. This is also CH3 group. Don't think that CH2 is better than CH3. But before that, what you need to see is most substituted. So which is most substituted part now? This is most substituted one. This is less substituted one. Here one hydrogen is there. So you need to go with most substituted one. So double bond you don't touch. This is not here, but in this place you will get. So very selective, you can say, this reaction is. And one other special reaction is if you are having cycloalkenes, then selenium dioxide can oxidize that too. Cyclohexene one, cyclohex 2-ene 1-one. First place, second place. This is cyclohexene. This is again one very special characteristics in cycloalkenes. The ring methylene group at alpha position is converted to double bond oxygen. This is the double bond to this alpha. This place is oxidized to ketonic group, not hydroxylation. This is ketonic group. But if it is already substituted, okay, and again one more condition is here. This condition is again very interesting. Double bond, if it is substituted by some group, then the next place is not ketone, but instead of ketone it is converted to hydroxyl group. No substitution is here, you can check. So that became ketone. Here substitution is there, so that became hydroxylation. When the cycloalkene is substituted on the double bond, the methylene group at alpha position to the substituted end of the double bond is oxidized. That oxidation is to alcohol. You can say alpha hydroxy cyclohexene. Alpha hydroxy cyclohexene. This is one very special case. And one double bond case is also there. That is again very special. Terminal double bonds are oxidized to primary alcoholic groups along with allylic migration of the double bond. See, if you are having pentene, this is one pentene. This is a terminal double bond. Now this terminal double bond will come inside and last place will become OH group. So if you are using selenium dioxide, very interesting reaction it is. Now this will become second place double bond and first place OH group. So pent 2 in 1 ol. See the statement again. Terminal double bonds. I'll show you the terminal double bond. This is the terminal double bond. Terminal double bonds are oxidized by selenium dioxide to primary alcoholic group. This is primary alcoholic group, and you can say allylic migration. Okay, now allylic migration means double bond is coming inside. Allylic migration of the double bond, you can say. So pent 1-ene is converted to pent 2 in 1 ol by selenium dioxide. Again, one very special reaction. It is also used for dehydrogenation. Dehydrogenation means we know minus of hydrogen. Selenium dioxide is used for dehydrogenation at high temperatures. So simply show with a delta. Temperatures must be high. See, if we are having a phenyl group and CH2OH, benzyl alcohol, selenium dioxide, CHO, benzaldehyde, and CH3COOH if you are using CH3COOH. Our intention is to remove the hydrogens minus H2. It will become CH2COOH, CH2COOH, a bond is formed. So from acetic acid you can prepare succinic acid. And if you are having like this is hexane 2,5 dione. These examples and concept is taken from Sanyal book. When you are using selenium dioxide at elevated temperatures, 1, 2, 3, 4, double bond O, double bond O, a double bond is coming. At high temperatures, losing hydrogens. And selenium dioxide can be used as a catalyst also. CH double bond CH COOH. If you are using H2O2, selenium dioxide functions like catalyst, and becomes CH2COOH. This is maleic acid converted to tartaric acid. One second. CH na C H will be there. This is COOH. H2O2 is oxidizing agent, one OH here, one OH here. This is tartaric acid. Tartaric acid is formed in this reaction. So these are some important reactions of selenium dioxide. Selenium dioxide first reacts with water to form H2SeO3, selenious acid. Selenious acid will be having double bond O and two OH groups. Because of these OH groups, you can see the mechanism, that is the expected mechanism. And the most important reactions are methylene groups, active methylene groups or methyl groups are oxidized. For engineering level entrance examination, these reactions are important. We'll go for a couple of minutes again. CH3CHO is converted to CHO. So this part is oxidized. In this case, this part is oxidized. Here, this is oxidized. It is oxidized. Then you can see this part can be oxidized, that is major product, and this part can also be oxidized. You can check here. This is oxidized. This part is oxidized. This part is oxidized. And hydroxylation of allylic position is again very interesting. When double bond is there, double bond is also mandatory. If double bond is there, this part allylic position, that is converted. Double bond is there, and more substituted, you have to check. This side is more substituted, in that CH2 group is converted. This is more substituted, so that is converted. When double bond is there, and if it is not substituted, double bond is not substituted, then alpha position is converted to ketone. But if it is substituted, it is converted to OH. Again, one exception type. And one terminal double bonds. Terminal double bonds are made into internal double bonds with primary alcoholic group. Dehydrogenation, CH2OH converted to CHO. And here you see two acetic acids are converted to succinic acid. One hydrogen from here, one hydrogen from here gone. And selenium dioxide, hexane 2,5 dione. This is 2,5 dione. And here double bond is formed. As a catalyst, this is one very important reaction. Hydrogen peroxide is a good oxidizing agent, hydroxylating agent, you can say. This double bond made into single bond, and here one OH group and here one OH group is joined. And this compound is called tartaric acid. So this is all about selenium dioxide. We will discuss about more in coming classes. Thank you.